Okay guys, today we're going to look at some volume. Now I wanted to start off today with the definition, just the general definition of volume, because I think it's really important. You know, volume is the number of cubic units needed to completely fill a 3D figure. You know, for much of the year we've been working a lot on 2D figures, and here we really quickly switch over to 3D figures, which is really important to keep in mind as well. Now, the other day I showed you a cereal box because I thought that was a great way to think of a 3D figure, or a rectangular prism, because in our case we were figuring out how many cubes fit in to a rectangular prism, which you see right here. So a couple of things I want us to look at today, guys, would include the following. The first thing you have to think of when calculating volume, because you're basically trying to figure out how many cubes would fit into this rectangular prism, or maybe we could even just call it a box. You know, think of this as a box, okay? Just a regular box. Maybe it's a cereal box, maybe it's a shoe box, something like that. We're trying to count how many cubes would fit into this entire figure. So we could just go ahead and count every single cube. We'd have to make sure we get all the ones on the inside that we can't see in this diagram, or we can actually calculate the area of one row, okay, or one of the base, okay, and then we can multiply that by the number of times that it's stacked up by its height, okay? So let's think about what I just said there, because it's kind of confusing at first, but if we think about it, I think it'll make an awful lot of sense. So first of all, we're going to calculate the fact that this is 1, 2, 3, 4 across, it's 4 units, and going back it's 1, 2, 3, 4 back. So if I just wanted to find the area of this very bottom portion, okay, of the base of this rectangular prism, I would take 4 times 4. We've talked about area before. That's exactly how I'd find it, and that would be 16 units, right? Now I have to think to myself, okay, how many times is this stacked up? Okay, how many times is this stacked up and down right here? Okay, well, I've already counted one time. That's what I've calculated, this one. And I have 2, 3, 4, 5. So theoretically, if I would take 16, because there are 16 in each row, and multiply that by 5, okay, if I take my 16 and multiply that by 1, 2, 3, 4, 5 rows, I should be able to find out the volume, or how many cubic units are covering this figure. So let's give it a try. So 16 times 5 would come out to be what, guys? 6 times 5 would be 30. Regroup the 3, that would be 80 units. And I always want to say cubed. Okay, 80 units cubed. It's cubed because we're literally counting how many cubes are fitting into this 3D figure. Let me give you another to make some more sense. Okay guys, so this figure right here, this kind of decomposes. This is what I was talking about in the last figure. This decomposes the rectangular prism for you. So if I literally took every row, if I took each of the stacks off of this rectangular prism, I would get 4 of these stacks. And essentially what I'm doing when I'm calculating volume is simply finding the area of one of them and then multiplying it by the height, how many times it was stacked. So if I do it the first time, the area of this is 1, 2, 3 times 2, that would be 6 units squared, right? Because I calculated area. But then if I take 6 times 4, because it's stacked 4 times, 6 times 4 is going to be 24 units cubed. So in this figure, I have 24 units, 24 cubes stacked up. Now you could also use the actual formula for volume, which is volume equals length times width times height. You get the same thing. Length is 3, width is 2, 3 times 2 is 6, times the height, 1, 2, 3, 4, 6 times 4 is 24. In real life, guys, swimming pools are an area where we do have to calculate volume, and in this such case, here's an example of a swimming pool that I have put here on the screen. Thought it was kind of cool. And you'd be calculating volume when you're trying to figure out how much water is going inside of the swimming pool. So my problem reads, this swimming pool has a depth of 18 feet and a base area of 162 feet. How much water can this pool hold? Now immediately we're trying to probably in our mind think of 3 numbers, am I right? Because we know the formula. If we memorize the formula, we know that's length times width times height. Well, the problem in this here is I have a depth of 18 feet and a base area of 162 feet. So So how much water can this pool hold? Well, depth simply means how deep, right? So if I was standing here on the side and I jumped in and went the whole way to the bottom, the depth would be 18 feet. If you've gotten to the swimming pool, you've seen that before. Now, the thing that they changed here is the base area. They've already calculated the area of the very bottom of the swimming pool, okay, which is something that we typically would have to do. That's why we don't have two numbers. So in this formula, 162 is really the length times the width. They've already done that. Now we have to multiply it by the height, and in our case, the height here is 18 feet. So we would have to take 162 times 18. If I multiply that out, here's what I am going to get. I am going to get 892. There are no decimal points, so this would be, this swimming pool could hold 2,916 cubic feet of water. Okay, that is the volume if we were measuring it in regards to that. So I put this problem on here, guys, because I wanted you to see an example of base area. That was the length times width. That's why we didn't have numbers. The classic example that I found, and I thought this was a great way to measure volume, guys, would be the Rubik's Cube, you know. So if I'm taking my formula, let's use the formula in this case, okay? Now we could count the number of cubes to figure out the volume, but we could also take the length, which is 3, the width, which is 3, and the height, which is 3 units. 3 times 3 times 3. 3 times 3 is 9 times 3. The volume equals 27 units cubed. So there are a total, if you would just individually count, there are a total of 27 cubic units on this Rubik's Cube. Okay? And finally, one more. Here's a pretty practical problem, guys. Follow along as I read it out loud. I have created a flower bed for the spring season that I would like to fill with dirt. The flowers will come later. The area of the base of the flower bed is 42 square feet. Okay, so I hear square feet, so it sounds like the bottom area, how much does it cover? How many tiles or how many squares would cover the bottom is already calculated. The height of the flower bed is 3 feet. Okay, height up and down. What is the volume of the flower bed? Well, this is another example of where they have already calculated the base area, which is very important. So, you know, the formula for volume is length times width times height, but another case where I do not see 3 different dimensions, I only see 2 right now, they've already calculated for you the length and the width of the base, and that was 42 square feet, times a height, that's up and down, of 3 feet. So your volume in this case would be 126 feet cubed. So you would be able to put 126 cubic feet of soil into this flower garden in order to fill it with soil. Now there's another practical example, guys, of how we use volume to calculate things like this. You know, if you built this, you would not want to go to Home Depot and just buy a ton of dirt. You'd want to get a specific amount, and that is the case there. If you guys are still looking for practice on volume, I would definitely visit our Class Fusion page where you can find a ton of links to continue your practice.